Students, in this video, we are going to see Chapter 6, Example 6.7. Prove by vector method that the perpendiculars, altitudes. So this is altitudes. Altitudes from the vertices to the opposite sides of a triangle are congruent. So we know very clearly, suppose if two lines are intersecting, then we'll call these two lines as intersecting lines because the point of intersection, okay, the point of intersection here only two lines are intersecting. So this is called intersecting point of intersection, or these two lines are called intersecting lines. But from the same point, if more than two means three or more than 3 points passes through the same point, then that particular point is called point of concurrency, or we can say that those lines are concurrent. Okay, so now here they asked us to prove that altitudes of a triangle are concurrent. Okay, they asked us to prove altitudes of a triangle are concurrent. Now, what do you mean by altitude? A line joining from the vertex to the perpendicular to the opposite side. So AD is one altitude, BE is the other altitude, CF is the third altitude. Now these three altitudes, if they passes through the same point, then we'll say that altitudes are concurrent. Now see the solution we are proving here by using vector method. Consider a triangle ABC in which two altitudes, so we have taken two altitudes in the beginning, AD is one altitude, BE is the other altitude, intersect at a point O. So let this point be O. Now let CO be produced to meet AB at F. So this CO meet to produce, okay, so just draw a line which meets AB at F. Now let us take O as an origin point. So let somewhere here in the triangle, let's consider O as an origin point, the point of reference. Now we know this OA is equal to A vector, OB is equal to B vector. So this OA, A vector, OB, B vector, OC, C vector. Let us consider these position vectors. Now, they've already given AD is altitude. So what does it mean? AD is perpendicular to BC. So AD is perpendicular to BC means what I can say? I can say even OA is also perpendicular to BC only. Okay, so AD perpendicular to BC, or in other words we can say OA is also perpendicular to BC only. So OA perpendicular to BC. So now if OA is perpendicular to BC means what we know? If two vectors are perpendicular, clearly if they are two vectors are perpendicular, we'll say that the dot product is equal to 0. Okay, if two vectors are perpendicular, see here, OA is perpendicular to BC, therefore the dot product is nothing but 0. Okay, so from this OA vector dot BC means OC minus OB vector is equal to 0. So OA is nothing but A vector dot OC is nothing but C vector minus OB is nothing but B vector is equal to 0. So this is what that they have done here. Next, after that, so according to the distribution method, A dot C minus A vector, you multiply it inside, so that you will get it as A dot B is equal to 0. Okay, so this is what that you will see here in these lines. So this, they have done the same way only. Now similarly, let's take BE. BE is perpendicular to AC. Okay, so now BE is perpendicular to CA means what does it mean? So BE is perpendicular to CA means I can say OB is also perpendicular to the same CA only. Okay, so OB is perpendicular to CA. So if these two are perpendicular means we know that the dot product is equal to 0. Now CA can be written as OA minus OC. So OA is A vector minus OC is nothing but C vector. Now apply the distributive property. So B vector dot A vector or A dot B minus B dot C is equal to 0. Now consider this as equation 1 and let this be equation 2. Now we are just adding equation 1 and 2. So now as you add equation 1 and 2, we'll get, what is the first equation? A dot C minus A dot B. Okay, A dot C minus A dot B. This is the first equation. Now what is second equation? This one. So plus A dot B minus B dot C is equal to 0. So clearly minus A dot B plus A dot B gets cancelled. Now from the remaining A dot C minus B dot C is equal to 0. So take C as common. We'll get C dot A vector minus B vector is equal to 0. So C is nothing but OC vector dot A is nothing but OA vector minus B. B is nothing but OB vector is equal to 0. So this is OC vector dot OA minus OB is nothing but BA vector is equal to 0. So the dot product is, these two dot product is equal to 0 means what does it mean? Those two are perpendicular. So clearly BA is perpendicular to OC. Okay. Now see here, the same thing only they must have done. So therefore BA is perpendicular to OC. So BA perpendicular to OC means, now see here, BA is perpendicular to OC. So OC, or I can say even CF. Okay, so OC is perpendicular to BA. We can also say that CF is also perpendicular to AB. Okay, CF is perpendicular to AB. So CF is perpendicular to AB, and hence the perpendicular drawn from C also passes through the same point called O. Okay, so the perpendicular drawn from C to the side AB passes through O. So therefore all these three altitudes are concurrent, because all these three altitudes are passing through the same point called O. So therefore they are concurrent.